Solid, shiny and sturdy, metals are the building blocks of the world around us. But what makes them so useful and interesting? Let's find out. Hi, I'm Dr. Stella Pedrazzini. I'm a university lecturer at Imperial College London. In school, I really loved science and I had this fantastic teacher who really nurtured that passion for science and chemistry. But I also enjoyed physics as well, and I wasn't quite sure which one I wanted to do at university. And then by chance, I was introduced to the subject of material science. I hadn't heard about it, but it combines physics, chemistry and engineering, so it sounded perfect. So metals are important because most of the structural materials that are around us are made of metals. If you're in a building, it will have a metal framework. If you travel to school by car or by tube or by train, whatever, most of our transport system is made up of metallic materials, and we don't want them to fail. So it's very important for us to be able to predict their lifespan, and we need to understand how metals work to ensure everyone's safety. As a lecturer at Imperial College, I run a research group. My research group is made up of researchers, students, PhD students and undergraduate students. And now I'm going to be handing over to them. They're going to show you the lab and do an experiment.
Hi, my name is Adam. I work with metals in this lab, particularly finding out the properties and the strength of them. Specifically today, we'll be looking at tensile testing of an aluminium sample. It's essential that we have the right metal for the right job, because you want to know why stuff will break and if it will break. So, if you think about your chair, if you go sit down on it and it breaks suddenly, it's not a very good chair. And it's the same for a wide range of engineering materials, from cars to planes. So first, you have to measure the sample. It's important for us to know the dimensions of the sample, as each test is specific to each sample. We can do this using a vernier caliper to work out the width and the depth of each sample, which is important to know the stress, which is force over area. The machine can work out the force, but we need to find the area. You then get the machine in the right position, load the specimen, and make sure to put the cover over the front, as you never know what might happen during a test. A piece of metal might go flying off. We then enter the measurements, which we have to of course record, into the computer, and then once they're in there, we can start the test. And the test will plot the strength of the metal, so the force it's applying to stretch it, and the distance on the bottom axis. And these two things can be later used to give us specific properties of the metal. The specific property we can test is the tensile strength and the Young's modulus of a metal. So that's how much force you need to have it to deform slightly and go back to its original shape. It's essential that we have the right metal for the right job. And so one of the key things we have to match up is the strength of the metal. So for example, you wouldn't want a spoon that was super engineered and could withstand massive strengths, and you wouldn't want a jet engine which had the materials of a spoon. And so tests like this can help us pick the right situation for the right metal.
One of the great things about being a material scientist is working on projects that really make a difference. Something that motivates me constantly is my team. By working together towards the same goal, we all push each other to be the best that we can be every day.